So, hello fellow Earthlings, this is Earthling 6455463728, and I agree with Richard Dawkins. Katalin Karikó and Drew Weissman should win a Nobel Prize for their work with respect to mRNA, and I'll get into that in a moment. Of course, I am Earthling, yada yada yada. I have lost almost 100 pounds and have kept it off. I've quit smoking. I have been a army reservist. I have a couple of degrees and traveled a bit, and that's it for me. So I clicked on a YouTube video. I wish I could remember who it was from. You know what? It was Bloomberg Quick Take, I think it was. And they were going over mRNA. But they started off in a very interesting way, in a way that I wish more scientific articles would start off with, which was the hardship of the person involved in trying to succeed at what they knew was possible, even in the face of, lots of disappointing pushback against them. Of course, you're not going to always succeed, definitely. For every one person that you have who may and should win a Nobel Prize, like Katalin Karikó, and subsequently the person that she met, Drew Weissman, you're going to have a whole bunch of other people who did not achieve the dreams that they wanted in life. But hopefully they achieved something. But starting off with the story about mRNA and its use in creating the several of the vaccines that we have now for the illness, as Grim Stephan says. Let's see if that works. It was really useful to see, because she was basically they were interviewing her, and she was saying how what is mRNA? Maybe a lot of you already know. I read about this a long time ago, and I think I still remember what it was about. Everybody knows DNA, right? And DNA needs to transmit its information from genes into proteins to do everything that we need in order to build muscles, in order to transmit nerve impulses, in order to build bone, in order to do everything. You need that recipe from the DNA to be turned into a protein. And basically the DNA opens up a bit so that a particular gene can be replicated. And what it's replicated into is messenger RNA. I hope I'm not getting it wrong, but yeah, I think that's how it works. And that messenger RNA in turn is copied into creating a protein. You might have several genes that together combine to make a protein. So you have that copy from the DNA that opens up for a little bit in order to get that copy made from messenger RNA, and that messenger RNA gets turned into a protein. So if you're understanding what I'm saying, the idea is that if you inject someone with that intermediary information from a messenger RNA strand that you, of course, injected into them, which I just said, if you can get the cells to mass produce that copy, and in this case, that copy of information from a virus, it's as if you have many, many copies of that bit of virus that are going to be circulating in your blood, and now your immune system can start to adapt to prepare itself for if it ever encounters that bit of protein in a real virus. Now the benefit to that is that you don't have to manufacture real viruses and then disable them or kill them, and basically your supply, most of your supply is coming from the body itself. You're injecting that bit of messenger RNA and you're saying to the cells in the human body, hey, go ahead, you manufacture more of this, and then your immune system gets used to it. As opposed to, on the flip side, the old way is okay, we have this virus, let's multiply it maybe in eggs or whatever else, and once we've multiplied it, maybe we go ahead and we disable it so that it's weakened and it can't do anybody anything, and we can inject that into people, they will react to it and know. But of course, if you can get the human body to actually produce this stuff itself, it means that you don't have to have as much of the triggering material as if it is that you were using a dead or disabled virus material. So that's one of the really big benefits to using mRNA technology, as well as mRNA can be used to get the body to do lots of other things as well. So, and as well as that, it probably can be developed in terms of how the mRNA is created, beyond the comparative manufacturing of viruses that you're going to later disable. It's probably a lot easier in the beginning to put together that mRNA strand than it is necessarily to try and fail with disabling or weakening the virus that you've manufactured in eggs, for example. Anyway, the idea was that Miss Katalin Karikó, she was saying that, well, they were interviewing her, and she was up against a wall, honestly, in terms of people not believing that this type of technology was ever going to amount to anything. And she was on a track to become a tenured professor, but as a result of her grant applications being denied because people didn't believe in the technology, she did not reach as far academically as she could have. But luckily for her, she met a man who was, I think, the head of immunology at another university. So obviously, in our patriarchal world, the fact that he was a man definitely lent credibility to what she was saying. And of course, being the head of immunology at this institution lent even further credibility. So I guess that was able to help her to get a lot further than she ever would have on her own. Seeing as, she started on this path before she was even had a PhD, as far as I know. So yeah, the two of them were able to, as I think the YouTube video was saying, they were able to write a groundbreaking paper that demonstrated that it was possible to use mRNA as opposed to other approaches like trying to get DNA, for example, through something like CRISPR, to get DNA directly into. So if you have a piece of DNA and you wanted to, GMO something, you could try to get that DNA into the organism as a permanent fixture of the organism. But if you can use mRNA, it means that you don't even need to try and fail to get that DNA into the organism. You just need to get the intermediary messenger RNA into the cell, and the cells can replicate that mRNA, or at least the proteins that mRNA is going to create, and pretty much do the same thing. And you can control it, as Ms. Karikó was saying. Basically, if you want it to stop, you just don't insert any more, you don't inject any more mRNA into the organism. If you want it to start back, you can start back injecting it into the organism. Whereas if you have it in the DNA of the organism, you really don't have quite as much control as you might have. So, if you want a kid to be really tall and some of the proteins that are involved in that, you can just inject the kid with mRNA. Of course, that's not probably what ethically we're going to end up doing, but You can use it to treat cancer and diseases, just like we're doing now with the illness, and it can work. And I was supposed to do another video on these two other people that science really did not take to, and I guess it's buried in the other ideas that I have for YouTube videos, but clearly there was just so much adversity that this woman faced in as someone without credibility, having to go up against all of these people. It kind of reminded me of Einstein. I don't know if Einstein had a little bit more of people were listening to him more because he was a man, but for her it really sounds like she went through a lot of tribulations and trials. Of course, she's on the opposite side of it now, and she can say that as long as she was in the lab, she was happy. Yeah, maybe you don't remember all the nights when maybe you cried yourself to sleep because of the problems. Well, maybe you're right. I don't know. I wasn't there. But there's that. Also, what was really so interesting about the YouTube video is that even after Miss Karikó and Wiseman, Mr. Wiseman, were able to show that mRNA was useful, there were still so many hurdles that still needed to be passed in order for it to be useful, which again kind of reminds me of the guy who made penicillin, because everybody assumes that, he made there was a lot of work that went into manufacturing large doses of penicillin. And there's another guy subsequent who had to develop the lipid container, I guess, that is what the mRNA is transported into the body so that it can get into the cells. And there was a whole, I think he said like the first 200 times that he tried to make that container that would get the material into the cells, that it didn't work. And then beyond that, I think there was some other work that had to do with the inflammation that the original mRNA would create in people, and they had to tinker with the nucleotides, I believe, in order to have something that would not cause inflammation and destroy the mRNA. It's one of those stories. I think the New York Times is the publication that I guess would have brought information about Ms. Karikó outside of the academic and maybe the medical world, which is really great to have, publications like this still doing the investigative work and bringing out stories like this. But really, in many ways, this might be an even bigger story than CRISPR. And we've heard so much about CRISPR. And the story of this mRNA being used the way that it is, I had never heard of it before. And yes, people maybe have already won or are going to win a Nobel Prize for CRISPR. But I agree with Richard Dawkins. Definitely, this lady, for going through everything that she did, and the guy that she met, Drew Wiseman, for giving her some of the air of authority that he did by partnering with her, as well as the other guy who had to come up with the lipid envelope, and the other people who had to reduce the inflammation. I think it's only 3 people that can win a Nobel Prize, but depending the promise of how this thing that it seems to have is just, honestly, it's so amazing that I would love to see her win a Nobel Prize, definitely. Anyway, maybe more of a boring one for people who like my Kim Kardashian stories, but that's just my opinion. Feel free to agree, disagree, like, subscribe, share, any of those great things, and give your feedback in the same way that you would like to have feedback if this were your YouTube content. Peace. Peace.